In this video, we're going to disassemble the Monsgeek M1 V5 TMR keyboard to see what makes it tick. It has a ball catch release mechanism, so you can take off the top pretty easily. There's the ball catch mechanism right here. There's gaskets on the side which are attached to the plate, but as you can see, they don't really move very much. They don't give very much. That's why I call it like a sandwich mount almost, because it's really this gasket stuck between the top case and the bottom case, and it doesn't move. It's not a lot of flex. The corners of the case have these rubber pads, so it's kind of force broken automatically with these rubber pads, which is good. That's kind of what the mounting looks like. Now you can also see on the top side of this, there's a metal, what seems to be like almost like a rivet. And those are the standoffs that are connecting the plate with the PCB. And when we look on the underside of the PCB, you will see the screws that go into those like rivet-like objects. Hold the PCB together with the plate. So here's the whole plate. And if you want to count, you can actually count all the standoffs on here. And there are a lot of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 standoffs between the PCB and the plate. That's a lot of standoffs. And these two standoffs are right next to, or right underneath the space bar, which is why the space bar isn't very loud and doesn't resonate very much. So that's why when the sound test, you hear the space bar, it's not nearly as loud as a normal mechanical switch because it has all these standoffs fixing the plate to the PCB. And it does that because otherwise you won't get the precision that you need to be able to accurately measure the movement of the magnet in the switch when you depress it and it moves by the TMR sensor. So now we're going to take a look at one of these sockets. In particular, we're going to look at a socket that actually has a mechanical switch in it. So this socket is a socket for the spacebar. In my other videos I told you, yeah, I like putting a mechanical switch in the spacebar because it sounds better, feels better. And here are the components. The center circle, that's the center pin, stabilizing pin of the mechanical switch, and where the stem bottoms out. The two little circles to the right and left of it, those are the stabilizing pins. The big thing below it, that's the Kale hot swap socket. So there's two actual metal pins that go into either side of that. And then on the top, this is the LED for the RGB. And then right next to the center pin is a TMR sensor. It's very tiny. In between this stabilizing pin and the center pin, that's the TMR sensor. The TMR sensor is not in the center of the switch because it doesn't actually, it can't sense the change in magnetic field directly above it. It needs to sense it to the side. So that's why it's also on the side of it. Hall effect switch usually detects something right above it. So you put the Hall effect sensor normally where this center pin would go. And that's why not many keyboards have Hall effect and mechanical switches available to them. I haven't looked on a Glorious keyboard yet, but I mean, I think it's possible still, if you just, depending on exactly how you orient the Hall effect sensor, that you could detect the center magnet still from the side somehow. But it would have to be, it couldn't be straight on. Like, you'd have to probably alter the exact mounting of the Hall effect sensor for that to work. But anyway, this is how the TMR sensor is mounted. It's just right next to the center of the stem. And that's pretty much all there really is here. I guess you can take a look at the bottom case. Bottom case has a layer of foam, has 2 batteries, and the ribbon cables for the battery, RGB, and then also for the volume knob. That's pretty much it for the M1 V5 TMR internals.